Hey guys, hope all is well. Today we are going to continue solving quadratics. So far we've solved them by graphing, we've solved them by factoring, and today we're going to solve it by completing the square. I would highly encourage you guys to watch the YouTube videos I post at the end of this. I know I plan on posting one by Mr. McLogan, one from Khan Academy, and one that's a music video that's a parody to Taylor Swift's Blank Space. I know, trust me, I know that most of my YouTube videos are pretty cringeworthy and pretty corny, but that one actually does a really good job of explaining the process of completing a square. And I will also show a proof, and a proof is something you guys will do a lot in geometry of why completing the square works geometrically instead of algebraically. I know I get really excited when I watch this because the professor gets really excited explaining it, and he even gets more excited after seeing how it clicks for his students and how excited they get when it makes sense to them. So please watch those videos as well as this one. This is a little bit of a tougher concept. Stick with me, you'll get it. But just know if it might not make sense the first time, watch the videos again, look through the music videos, look through the YouTube videos, and I promise you are fully capable of understanding this stuff. So let's look at the very first example here. So if you notice on the left hand side, we have a bunch of steps, and this will be the kind of your checklist of what to do first. And step one says if A does not equal 1, divide both sides of the equation by A. And if we look at our equation, right now our A, even though we don't see it, we see it, but we don't see its coefficient, it does have a coefficient of 1. So our A term is currently 1 already. Step 2 says rewrite the equation so that the constant term is alone on one side of the equal sign. Well, the only term without a variable is already on the right hand side. That is our constant. So step 2 is also already done. Step 3 says square half the coefficient of x term and add this square to both sides of the equation. So if I look at it, what is my x term? My x term is right here, and my x term is negative 16. And my directions for step 3 say square half of the coefficient of the x term. Well, what is 1/2 of x? Well, if x equals negative 16, 1/2 of that would be negative 8. But it says I don't just half it, I half it and then I square it. So if I square negative 8, that would give me 64. And I add that to both sides of the equation. So the way that's going to look is it's going to say x squared minus 16x. And I'm going to add that to both sides of the equation, the half squared of my x term. So I'm going to add 64 to both sides of my equation. So if I look at that, why did I do that? What's the purpose of halving it and then squaring it? But the reason I do that is if you notice on this left hand side of my equation now, I have x squared minus 16x plus 64. And if you look at it, the very first term, my a term, is a perfect square, and my c term is a perfect square. So if you think back to factoring, I can now factor this using the property of perfect squares, and I can say that this right here is the exact same as x minus 8 squared equals, and negative 15 plus 64 equals 49. And you'll also notice that my term that goes inside my parentheses, the part of my binomial, will always be the same as half of your x. There's a reason those are similar, because that's the way it works. So now that I've half my x term, squared it, and added to both sides, and then factored my trinomial on the left-hand side, I can now solve these the same way we solved last week's problems by taking the square root of both sides. My square root and my squared symbol would cancel out, leaving me with x minus 8 equals, well, that'd be the square root of 49, which would be plus or minus 7. And just like last week, this is going to leave me with two different answers. I'll have to say, well, what happens when x minus 8 equals positive 7? And what happens when x minus 8 equals negative 7? So I'd go to the side of the variable and do the opposite to both of these equations. I'd add 8 on this side, add 8 on this side. Those would cancel out. I'd be left with x equals 15. And I would do the same thing on the right side. I'd add 8, add 8. They cancel out. I'd be left with x equals positive 1. And those two values are your roots, are your solutions to this quadratic equation. So if you don't get it yet, don't stress. More examples to come. But